So you have your log base 5x is equals to f of x. Now this can be converted, meaning f of x, you can just make that your y. So let me just go y is equals to, and I'll rewrite that side as is log base 5, and x, which can be changed to 5 to the power of y is equals to x. So once you have this exponential function here, you can be able to solve these questions. Now for me to be able to explain or draw the above function and answer the following questions, I won't even draw it. I'll go to a previous exam question paper which had the function. So this is the previous exam question paper, where if we look at the intercepts, so we go horizontal intercept firstly. So for the horizontal intercept firstly, we have to let y equals to 0, right? So y should be equals to 0, and therefore 5 to the power of 0 is equals to x, and we know that x is equals to 1. So it means that at point, let me put the points up here, at point where x is 1, y is 0. Now we go back to the graph. The point is that right there at u. If you look at it, it's right there. So this point here will be your, okay, let me just write it down for you. This point will be 1 and 0, right? So hence we can be able to draw the graph. Now going back again to the question, it asks us the domain, right? The domain, use interval notation. So going back to the graph, if you look at the graph, it's basically not passing 0. So this is point 0, and the graph basically never touches 0, or it starts at 0, because we do know that for our domain we will have, because if you look at the graph again, as it goes to the right, it's going to infinity. It's always rising, although at a decreasing rate, but it's still going up to infinity, right? So we know based on the graph that our domain will be somewhere between 0 and infinity, right? So this is basically the or sets of all input values for x, right? It's from 0 to infinity to positive infinity. Now let's look at the range again in reference to the graph, right? So if you look at your y, clearly this curve will go down forever and it will go up forever, and therefore for our range we clearly would have negative infinity to positive infinity. That's using the interval notation. So we found those 2 points, and we found the horizontal point. As for the vertical intercept, well, we can then substitute x for 0, right? X will be equals to 0. So when 5 to the power of y is equals to 0, clearly you cannot have a number to the power of 5 to the power of anything which will give you a 0. Therefore this does not exist. on the curve, right? So this point does not exist, and we therefore have to look at the next question, which is our vertical asymptote. As for our vertical asymptote, we're going back to the graph. The vertical asymptote basically is telling us that it's this line here. So for our vertical asymptote, we do know that x will be equals to 0, because as you can tell, this graph will never touch 0, right? So I will then put down the 0 for us. So for our vertical asymptote, x will be equals to 0. That's for the vertical asymptote. So values of x for which f of x is greater than 0. Which values of x? Now let's go look at this. Which values of x? Which values of x when f of x, which is the y, is greater than 0? So it's essentially telling us the values from this point here and above, right? So, and we know that values of x for which f of x is less than 0, it will therefore be this side, right? So how do you actually write that information down? You can then start off by saying, okay, when x is greater than 1, right? So those are the values of. So to answer this question here, using inequality notation, I'd say when x is greater than 1. So all the values when x is greater than 1 are the values of x they are looking for here. So the values of x for which f of x is greater than 0. So when f of x is greater than 0, it's there by 1 and beyond. So x is greater than 1 and beyond. Now, values of x for which f of x is less than 0. I've just indicated it on the graph. So the points will be somewhere between 0 and 1. So how do you then denote that? So for that, I will go back and say, okay, when 0 is less than x and less than 1. So somewhere in between, less than 0 and less than 1, x can be found for the values of x for which f of x is less than 0. So I hope you can understand how I'm putting it, right? So this was it for the day. I will explain further using other examples the following function, right? Because we've done a lot of these functions, and we can then start drawing them and practicing using the same method that I used here.